Hey ladies, so today we're starting a new chapter. We're starting chapter 7, exponential functions. I know we studied trigonometric identities, the graphs, the unit circle, studied that for quite a long time, so I'm sure you guys are probably excited to get into something else. Just as one quick note, this unit's only 6 hours, including our test time and review, so it's really short, so just note that here we don't have our midpoint quiz. There's only 3 sections, so it's going to go by pretty quickly there, so just keep in mind with those due dates that are going to be coming up. And looking at the outcomes for our unit, we're going to be sort of accomplishing 2 this unit. Our first one there is we're going to be talking about transformations, which we've already been working towards in the previous units, but this one, it also helps work towards the transformations of functions outcome there. And then the second one there mostly talks about logarithms there. And within this unit, we have to relate logarithms to exponential functions. So this is more of an introduction unit to this outcome. So it'll be a good introduction to our next chapter, which is chapter 8. Okay, and we have some key terms there. So we have exponential function, exponential growth, exponential decay, and exponential equation. 3 or 4 of those we are going to see actually in our first section, which we're going to look at today. So it'll go by pretty quickly there for you guys. So today we're going to be looking at we're looking at characteristics of exponential functions, and I give you a quick little blurb there. It's kind of a neat little story, I guess, introducing our units. So quickly pause the video, give it a quick read, and then we'll move on with our lesson. Alright, so hopefully you guys had enough time to read that. So it's a really kind of interesting story about how 1 grain of rice can grow to be so big, and we actually write that as an exponential function there. So looking at this one right here, we can actually write that above situation as y is equal to 2x. So the first grain of rice, or the first square that he had was 1 grain of rice, then it moved up to 2 for the second, then 4, and then 8, and so on. So we're looking at an exponential function there, okay? And if you want to look at those values here, I guess we could even write that in. So the first one would be 2 to the 0, because that's equal to 1 grain of rice. Our second one, we had 2 to the 1, that is 2 grains of rice. Then moving on, we have 2 to the 2, that's equal to 4, and then so on. So we can write that as an exponential function, y is equal to 2 to the power of x. Okay? So then getting on to that definition, so an exponential function exponential function is a function which can be expressed as y is equal to c to the power of x, where c is greater than 0. So c is an actual number, and then we're dealing with our usual variables y and x. Alright, so moving on down here. So when graphing exponential functions, there are different values of c that we will consider when we graph, and these in itself will actually affect the shape of our graph. So in our first case here is when c is greater than 1. So what we're going to notice that is that the exponential function is increasing. And this here we call an exponential growth. So just remember that this pattern, so remember when we read graphs, read them from left to right. So as you notice, those y values, they start out really, really small. And I guess one point here is that it also looks like they're touching that 0 point there. But there's actually an asymptote there, so there are really, really small fractions there. And then as we get into the more positive values of x, our graph is increasing, so it's increasing from left to right. Okay? So moving on. So what about when c is equal to 1? Well, with that kind of a graph, we're looking at, say we put in y is equal to 1. Let's put in x is equal to 1. That is equal to 1. Y is equal to 1 squared. That's equal to 1 times 1. That's 1. So basically what we're going to be looking at here is we're looking at y is equal to 1. That's the kind of graph we're looking at there, okay? So it's not increasing and it's not decreasing. So our graph here, as I just said, is just going to be y is equal to 1. So there's, I guess, an example of, an exponential function that really isn't an or it's not really doing much of anything, okay? So another case, a third case here is that when we have c is between 0 and 1, and some important notes, it's not equal to 1 or equal to 0, it's in between those numbers, so they're going to be fractions. So here we have this example, we have y is equal to 1/2 to the power of x. And here what you guys will notice that as you're reading it from left to right, so as our x values are getting larger, our y values are actually getting smaller. So this decreasing pattern, we'll call this exponential decay. Alright, so let's repeat that again. So your exponential growth will be increasing. So we'd have that example where y is equal to, say, 2 to the power of x. And then your exponential decay is when we're dealing with fractions. That one, your values are decreasing as your x values are increasing. Okay, so we'll look at these a little bit more in depth through some examples, but this is just to get you started. So another case that we could have is when we have c is equal to 0. And so it's kind of similar to c is equal to 1. So for the most part, we're going to just create the graph y is equal to 0. And we will have this restriction that x has to be greater than or equal to 0. And also maybe what we can also say is that when x is equal to 0, y is equal to 1. It kind of creates this funky graph where, say if we were to plot this there, we'd have our, say, 1 there. So at 0 and 1, then the rest of it's going to be on your x-axis, so when x is equal to 0, or y is equal to 0, sorry. So if you guys want to see an example of that, so what happens, why do we need to have this restriction of x has to be greater than or equal to 0? When x is, say, let's go x is equal to -1. Now remember, when you have a negative exponent, that flips it, so what we're going to have is 1 over 0. That is undefined, or if you guys put that in your calculator, you'll get a syntax error. So that's not actually a value, so it's undefined, okay? So that's what happens, and with every other case when you have a negative exponent, that's what's going to happen. Okay, so then looking at 0 to the power of 0, remember any number with the exponent of 0 will just be 1. Okay? Then say, let's look at 0 squared, that's equal to 0 times 0, and that's just equal to 0. So when your value here is negative, your exponent there is negative, you'll have undefined. When it's at 0, when x is equal to 0, you'll have y is equal to 1. And then every other value that is positive for x, you'll have y is equal to 0. So it kind of creates that really strange graph. So there's a really quick tidbit. So we're not really going to look too much into c is equal to 0 and c is equal to 1. They're not very interesting to look at. So we're not going to study those. Okay. So moving right on along, we're going to look at one last example, or one last case. So what if c is less than 0? And we're going to take, for example, we have y is equal, or say we have -2 to the power of 1/2. And ladies, you will need to make this adjustment into your notes. I apologize, I didn't notice this until after I printed them out, so make sure you change this to 1/2, or else that example is not going to make any sense, okay? So let's take, for example, -2 to the 1/2. So rewriting that, -2 to the 1/2 is equal to the square root of -2. And if you guys recall, everything with an even index cannot contain negative values, or else what we have is imaginary numbers, and we are not going to go there in this course. That is not something we need to touch. So in any case, when we have c is less than 0, we're going to get these crazy values, and it's actually not even going to create a nice graph. We're going to end up with, like, say if we even had an even index, so say we had -3, if we had that one cubed there, we'd have -27. And then what if we had -3 to the 4? That's going to create positive 81. So we're going to end up with this graph that is like bouncing up and down everywhere, and it's just not even going to create a nice graph. So we're not even going to bother with that one, okay? So I'm just going to quickly delete this thing here. So what we can say in general so looking at all these graphs that we kind of looked at, so the biggest ones here are when c is greater than 1, and then when c is less than 1 but greater than 0, so when it's a fraction. So we can kind of make some generalizations about, I guess, when we have exponential functions in the form of y is equal to the c of x. And this is when c is greater than 0, but we can exclude 1. Okay? So we'll just look at the fractions and then when we're bigger than 1. Alright, so looking at the domain, if you guys look at let's look at those two graphs where we have exponential growth and exponential decay. And we can kind of make a little generalization there. So we can say that we'll have our parentheses x such that, remember this bar here means such that, x is an element of all real numbers. And we'll close that parenthesis there. Then we'll look at the range. If you guys compare that, we have y such that y must be greater than 0, where y is an element of all real numbers. And I can further explain that a little bit. So why won't we ever have y is equal to 0, or why can't y ever be negative? So just even let's look at an example. So let's look at 2 to the negative 1. That's equal to 1/2. When 2 to the negative 2, we have 1/4. When we get bigger, say let's go 2 squared, we're going to have 4. So it actually, to get a 0, you either need to multiply that number by 0, or you need to subtract by the number itself. So there's really no case when we're ever going to have y is equal to 0. And then whenever we square something, or when we're dealing with positive numbers here, so whenever we're taking exponent, we're always going to have a positive value there. So I guess there's a quick tidbit on why we'll never have y is equal to 0 or less than 0. Okay. Alright, so now let's look at our horizontal asymptote. So remember our asymptotes, that is when our graph will never ever cross that line. So what we can say there is that's going to be dealing with our range, y is equal to 0. So looking at either of those two graphs, I guess your graph it'll get really close, but it will never actually ever touch 0, and it will never go into the negatives. So we could say that our horizontal asymptote is at y is equal to 0, so we'll never cross that x-axis there. Okay? And so what can we say, what is the y value when x is equal to 0? And looking at either of those graphs, what you guys will see is that when x is equal to 0, let's actually scroll up and let's look at that. So in this case here, when x is equal to 0, y is at 1. And going up to the first one here, when x is at 0, y is also at 1. What a coincidence. Alright. Alright, so what we can say is that when x is equal to 0, y will always be 1. And just remember, that's going to be for the section. Next section, we're going to look at the transformation, so that will change. But when we're dealing with y, or with an exponential function, y is equal to cx, or c to the power of x, it's always going to follow these kind of general rules, okay? So I'm going to pause the video here, and we're going to go on, I'm going to stop it, and we're going to go into video number 2 to finish off those examples. Make sure you guys have your graphing calculators out. We're going to be using our graphing calculators to do the next examples, okay?